The world pandemic crisis, novel coronavirus COVID-19 disease has become the hottest discussion globally. The first outbreak of this disease occurs since December 2019 that caused acute respiratory syndrome. It happened in Wuhan, Hubei province of China. Now the virus has spread to almost all countries in this world. In Malaysia, the outbreak of the virus has caused the local government to carry out different strategies to combat the virus. For instance, Movement Control Order (MCO), Conditional Movement Control Order (CMCO), and Recovery Movement Control Order (RMCO) are executed at different phases. A lot of standard operating procedures (SOP) are issued to allow the people to adapt with the situation and live in a new normal. People are advised to wear a face mask when leaving home and practice social distancing of 1 meter. Besides, temperature checking is performed to an individual before entering a place.
In compliance with the new normal, our group has designed a system which is able to perform 4 functions. They are temperature checking, face mask detection, customer counting and social distance monitoring. Our system is able to reduce the risk of infection in the community and consequently maintains a positive growth in the economic sector. Moreover, our system is also able to reduce the waste of resources such as paper by using electronic counting method. The system is made by using contactless IR temperature sensor, IR sensor, buzzer, and LCD module which are controlled by Arduino Uno R3. Besides, USB cameras are used and processed by using laptop.
Hello everyone, since COVID-19 cases are increasing every day, therefore we Group 27 are introducing real-time contactless COVID-19 detector system for closed area to ensure people will following SOP and to reduce unnecessary human contact.
Before we develop the product, a user survey is carried out. And from the survey, we found out that the automated temperature scanner is preferable over a traditional one. This because the automated temperature scanner is a contactless scanner. It's believed that it can reduce the risk of the infection. Next, we have found out that the card or tag numbering is not safe for the counting of number of customers. They will be risk to get infected. Moreover, face mask is crucial to halve the infection. Therefore, a face mask detection system is needed. Besides, from the survey, it's believed that people do not practice social distancing in a store. Hence, a social distance monitoring function is included in our product. These are the components which are used in this project. They are temperature sensor, IR sensor, buzzer, and LCD module. They are controlled by Arduino Uno board. Next, we have USB cameras which are used to capture image and processed by the laptop.
I will continue the design and discussion. For the first one is the temperature scanning system. As can you see at the flow chart, the system starts by detecting a person. If we detect that it scans the temperature sensor and also displaying it on the LCD. If the temperature is below 37.5 degrees Celsius, then a beep sound will come out. But if over 37.5, then the alarm will ring. So we did experiment to detect the working distance for the temperature sensor to the forehead. So as the conclusion, we find out that the best working distance is around 4 cm. So with this working distance, we do some experiment. of 5% and detect the error between the USM temperature and also our system. And can you see the highest error is around 0.58 degrees Celsius. So I go to the second one, is the customer counting system. Same goes to the temperature. We look at the flowchart. The flowchart, you can see there are two IR sensors. The first one is the sensor at the entrance, and the other one is at the exit. So both sensor will detect the presence of person entering and also exiting a closer area. So it make calculation and display the total number of customer on the LCD on the screen. If you see the example there, this is the 5% and also full, which is we limit at the coding 10, for example. So during the checking the sensitivity, as you can see, during the entering and the leaving, both give zero error. Therefore, as the conclusion that our system give 100% sensitivity.
I shall continue on with the results and discussion. Let's move on and look at the mask detection system. As the name implies, this system is made to detect whether or not customers are wearing a mask. As you can see in the background, the image shows how the system works. It is very intuitive. It draws a box around the faces of people and make it green for people with masks and red for people without one. Improper mask wearing techniques are also able to be detected, like the image shown in the background. On the left hand side, you have a person wearing a mask while exposing his nose, and on the right, you have a person trying to fake wearing a mask by covering his face with the mask, both of which is determined as not wearing a mask. For exotic mask lovers out there, do not worry, as most unique masks are also detected as masks. Here, we can see the tabulated data for our performance test. The mask works very well on normal disposable masks, scoring a 93.33 success rate and a 70% success rate on fabric masks. The system works flawlessly when detecting people without masks entirely, with a perfect score of 100% success rate. For troublemakers, 60% of the time, they will be caught with a red box. Now, let's go into social distance detection system. The system is made to enforce the 1 meter rule while within confined spaces. It detects whether or not two people are within 1 meter range of each other, like shown in the slides. The system works better when higher up to get a bird's eye view of the area. Calibration for the working system can be done mathematically or it can be done analytically. We found out that by setting up the camera first and adjusting the pixel per meter values with two people standing 1 meter apart works just as well as actually using the formula. First, we vary the values at a large interval like 50. When we find the boundaries, we fine tune it by using smaller values like 5. This will get us the correct working distance.
There are 3 points in impact part. First, in community, our system can reduce unnecessary human contact, alleviate infection, and protect vulnerable people. Next, in economy, it can keep economy going and help economic growth. Lastly, in environment, our product can reduce waste of paper, especially for customer counting system. Thank you.
These are the purchase component in this project. The first is the IR temperature sensor and then the camera, IR sensor, Arduino Uno R3, breadboard, another IR sensor, mini breadboard IR sensor, buzzer, mini breadboard, and the shipment fee. And the grand total for this project is 217 ringgit and 64 cent, which is within the budget of this project. Thanks for watching and have a nice day.
That is all from us today. Thank you very much. If you have any questions or feedback, feel free to let us know and we will be very happy to hear it out.